Okay, so welcome to the speed control of DC shunt motor, and this is our panel. What we'll be using here is a DC power supply. This is the variable power supply which we will be using, and again we have some fixed supplies, but we'll be using this variable supply. Also, there is a rheostat which we'll be using for the speed control or to control the field or the shunt sorry the field winding, the current of field winding. So these are a few things we'll be using in this panel. Other than that, we have a lot of things in this panel, like we have meters here, voltmeter, ammeter. These are all DC meters, but we will try to use the multimeters to get the accurate reading. Then there is a load indicator for torque measurement. In the motors, you can see that we in the left side we have a DC shunt machine. This is mostly used for the dynamo purpose or generation, and we will be using the machine on our right, that is the this is also the shunt machine. So again, it has like the field connections and the armature connections, and then there are two spare connections to be used in case of any damage to the main or the primary connections. Then again, there is a load as well, but we will be using only the DC variable supply, the rheostat, and this machine, and the speed will be measured here at the shaft. So let's start with the connection of this variable supply to this voltmeter. So simply what you have to do here is that you have to connect both the terminals to this voltmeter. So here you go. This will show you the voltage. Then next, what we want to do is that we want to connect this terminal, the positive terminal, to the rheostat and then to the field winding. Okay, so next what I am going to do is that I am to connect this connection from the positive of this supply to the rheostat. So this is the in. We will be using the input here input will be here and the output will be here. So which means that this will be the clock, you say anti-clockwise, it will be the minimum resistance, and the resistance will increase when we will turn this clockwise. So and if you connect the input here, then this connection will be reversed. But again, we are going according to the labeling. As you can see, minimum and maximum. So input will be here, output will be here, resistance will be increased clockwise and decreased anti-clockwise. So what again I want to do here is that I want to connect this this rheostat, the output of this rheostat, the variable output, to our F1. This is the F1 or the field winding. But again, we want to measure this current as well. So what I'm going to do is that I'm going to connect a ammeter here, but in this case I'm going to connect a digital ammeter. See, I have set it to this one is for AC, and now there you go. I hope it focuses. Yes. So 20 amperes AC and the DC, sorry, and the connections will be at A, and at common it will be connected in series with our system. So let me just clarify these connections. This connection, and then it comes all the way here, and then the common, it goes to the field winding, which is the F1. So this is now how it is connected, and also I will label it as IF. Okay, so this will be your field current. So let's see where we will adjust them. But right now I'm going to set it here somewhere so that these are not visible for now, but it will be visible later on. Okay, So next up, we want to connect the armature, and again for the armature we have to get a connection from the main supply. Either you can go here or you can go here as well at the input of this rheostat. So again this one is accessible, and again I want to measure this current. So again there is another ammeter with a 20 amperes setting, the scaling of 20 amperes DC. So here you go. So I hope that this is visible. I'm going to get it here. So connection will be this way, and then the A, and then this will be coming all the way to A1. Now this will show us the armature current, so that's why I will label it as IA. So here you go, this is the IA, and these are the connections. Now the negative or the common or the ground, so it is simple, just connect them with each other, as this is a shunt connection, and then just connect this connection to the negative of the supply. So just give me a second so I can connect it. So now the connections are complete, and as you can see that what we have done here is that we have connected the positive and negative of this variable power supply, DC power supply, to a voltmeter. This is a shunt connection or parallel. Then the positive of the supply, again I'm just going to change this like here so you can get a good overview. So the positive of the supply is coming all the way to the you can say the input of the rheostat, and then the output of the rheostat is given to the field winding. This is the field. Okay, so again this one, the first one is the field, and then again at the input we have taken the connection. So you can take this connection from here or you can take it all the way from here. So this one was accessible and we have connected it, and now both the connection are connected using the ammeter. So there is a ammeter connected in series with both the field and the armature winding. So let's go towards the readings and see how the change in the magnetic flux varies the speed of your motor. Okay guys, so what I have done here, I have just rearranged the meters so you can get a good overview of the meters, and then also the voltmeter and also the shaft as well, so you can take the readings. So now what I'm going to do here, what I have done here, I have set this to the minimum limit, and I'm going to turn on the supply. The voltage is again on the minimum, and just first turn on the emergency switch, and then the breaker, the supply, and now let's move it. So now you can see that there is negative reading here, so never mind. So you can see there are negative readings, so it doesn't matter, because the current can never be like it is flowing from left to right or right to left. So all you have to do is you have to change this supply on the ammeter. So you will face a lot of situations like this, so it doesn't matter, so you just toggle these or swap these connections, so it will be fine. So let's see now again. So it's better, it's good now, as you can see. So one thing, this is IF, I have written it as IM. So again I am going to change this. This is IF actually. So there you go. And sorry, this is IA. So let me check, cross check again. Yes, so this wire you can see this is coming to the armature. So this is IA. So IA is for the armature current and IF is for the field current which we have connected to the rheostat. So first of all we will what we will do is that we will stable the motor at a constant speed, and then we will vary this to see the effect of resistance onto the field, onto the speed. Okay, now so let's start it. So now the IA is 1.28 or 1.29 and the IF, the field current, is 0.09. Let's see what the speed is. So this is the tachometer which I'll be using. It's a UT373 and it is set on the RPM. So let's see. So as you know, this is a handheld set, so again the readings can be different. So this is around like 1474.6 RPM and I hope it focuses well. So there we go. So now let's increase the resistance here and then we see what happens to the speed. Now you can see that we have increased the resistance and now the IF is decreased to 0.08 and the speed is increased. So let's see again. Now the speed is 1568. So you can see that by increasing the resistance and decreasing the current, decreasing the field current or the flux, the motor speed has increased. Like it is now 1568. Okay, so it has increased around like from 1400 to 1500. So now this is 0.07 almost, and let's see what is the speed. So again you can see that the speed is now increased around up to 1606. So now it is a major increase in the speed by decreasing the field current. Now the IF is 0.06. And once again a huge increase in the speed G, 1733. So now this by increasing, like we are just decreasing the current by 0.01 and you can see there is 1000 RPM increase in the speed.
0.05. Increase the line.
And the speed is increased up to 1827. So again a major increase in the speed, like 1000 RPM. So students, this was the experiment, and you saw that by increasing the resistance of the field or the rheostat connected in series with the field, we were decreasing the field current, and what we saw is that the speed of the shaft was increasing. So that's all for the practical, and let's move towards the conclusion, graphs and measurements.